Alright, so now I'm going to do numbers 5 and 6, which says to solve each system by the elimination method. Elimination is when you add or subtract both of the equations in order to get something to eliminate or go away and become 0. In the first equation, I'm just looking over it and I'm looking for numbers that are the same. In this case, 3y and 3y. Now, because these are the same number, I can subtract the two equations. What's going to happen when I subtract 3y minus 3y is that's going to become 0, which is what I want to happen in the elimination method. So I'm going to go through step by step and subtract everything. 12x minus 5x is 7x. 3y minus 3y is 0. That's what they call it, elimination, is because the y's are now eliminated, they're gone. And 18 minus 4 is 14. The great thing about this is now I have one equation and it just has x in it. There's no more y's. So now this is possible to solve. So 7x plus 0 is the same as just 7x equals 14. And to solve this, I would divide both sides by 7. And I get x equals 2. And so that is my value for x. Once I figure out what x is, I'm going to plug that into either one of the first equations to figure out what y is. I'm going to use this bottom equation right here because the numbers are smaller, so it's probably going to be easier for me to figure out what y is. So I have 5x, but remember, instead of x, we're going to put 2 since we figured out x is 2. So 5 parentheses 2 instead of x plus 3y equals 4. So I just copied this bottom equation down, but instead of x I put a 2. And now we can solve it for y. 5 times 2 is 10. So then we have 10 plus 3y equals 4. Next I'm going to get rid of 10 by subtracting it on each side. 10 minus 10 is 0, so I get 3y equals 4 minus 10, which is negative 6. And feel free to use a calculator on any of these, like if you feel like you can't do it in your head. No problem with using a calculator. Next, to get rid of this 3, I'm going to divide both sides by 3, and I get y equals negative 2. So then my final answer would be my x value, which is 2, comma, my y value, which is negative 2. And remember on your test to write each answer as a coordinate like this to get full credit. Alright, so now I'm going to move on to problem number 6, and once again I'm looking for any numbers that are the same, and in this case they're not the same. 2 and 6 are not the same, and 7 and 5 are not the same. There are a couple different ways to do this. I could, for example, multiply the top equation by 6 and the bottom equation by 2, just switching these two, the 2 and the 6. Or I could have multiplied the top equation by 7, or sorry, the top equation by 5 because of this 5 right here, and the bottom equation by 7. That would help me eliminate the y values. But there's an even easier way than that. So that method will work, and if you do it that way, you'll get the same answer. But one thing I notice is that 2x goes into 6x. So what I can do is just multiply this top equation by 3, multiply everything in the top equation by 3, so that this 2x will turn into a 6x. And then I can eliminate it. So 3 times 2x is 6x. 3 times negative 7y is negative 21y. And 3 times 41 is 123. And so that's the nice thing about math, is there's multiple ways of solving something, and you get to pick whichever way you want. Now that they both have a 6, I'm going to subtract the two equations. And I know that I have to subtract because if I added 6x plus 6x, I would get 12x. That's not eliminating anything. Whereas if I do 6x minus 6x, that is 0. which eliminates the x. Next, I'm going to do 5 minus negative 21. 5 minus negative 21 is actually positive 26y. And once again, use your calculator if you feel uncomfortable with that type of calculation in your head. Next, I'm going to do negative 7 minus 123, which is negative 130. And now I can solve this for y. And do a little shortcut and just divide both sides by 26. And y equals negative 5. All right, now that I know what y is, I'm going to plug that in for y in one of the original equations. Since I used the bottom one last time, I'll use the top one this time just to switch it up. So I have 2x minus 7. Instead of y, I'm going to put negative 5 equals 41. So I just plugged in negative 5 for y in this top equation. Now I'm going to do negative 7 times negative 5, which is positive 35, equals 41. Then I'll subtract 35 from each side to get rid of the 35, and we get 2x equals 6. Divide both sides by 2, and I get x equals 3. And I would write that as 3 comma negative 5. Alright, so that's how I would do problems 5 and 6. I just found a way to scroll down without having to create a separate video for everything. So I'm also going to do problem 7 and 8 in this video. And on problem 7 and 8, as you can see, I can solve using any method that I choose. So here I have some freedom, but I do want to think about, okay, what method is going to make the most sense or be the easiest to use. Looking at the top equation, there's actually a couple methods that will be easy. I could rearrange this fairly quickly by solving for x or y, and then use substitution by plugging that into x or y in this equation. But what I'm going to do instead is, one thing I noticed is that 4 goes into 12. So what I could do is multiply this top equation by 3. So this 4x is going to turn into a 12x. So 3 times 4x is 12x. 3 times 4y is 12y. And 3 times 8 is 24. And so now I'm going to use elimination. I'm going to subtract the equations because I know that 12x minus 12x is 0. 5y minus 12y is negative 7y. And negative 4 minus 24 is negative 28. Then I'm going to divide both sides by negative 7. And I get y equals 4. And then I'm going to plug y back into the top equation. So I get 4x plus 4, and instead of this y right here, I'm going to plug in 4, since I now figured out that y equals 4, equals 8. And solve this. 4 times 4 is 16. Bring down the 4x. To get rid of the 16, I'm going to subtract 16 from both sides. This goes away, so I just have 4x equals negative 8. Divide by 4, and I get x equals negative 2. And I'm going a little bit faster since I've already done a problem similar to this before, but feel free to pause the video or replay it if you feel like this was too fast. Alright, so my final answer is negative 2 comma 4. Alright, so I chose to solve that using elimination. You could have used substitution as well, and you would get the same answer. Just pick whatever method you feel most comfortable with. Alright, on problem 8, I noticed that y is already by itself right here. So what I want to do on this one is actually substitute this expression, negative 2x plus 5, in place of y in this equation down here. So let me show you what that would look like. So I'm putting negative 2x plus 5 in place of this y right here. So I'd have negative 2x plus 5 equals negative 8x minus 1. And that was fairly quick to just substitute that right in. So now I want the x's to be on the same side of the equation. I'm going to add 8x to each side. I could have added 2x, but I knew that this would make a positive 6x. Bring down the 5. Bring down the negative 1. After I get x on the left-hand side, I want to get the term without x on the right-hand side. So I'm going to subtract this 5 right here to get rid of that, and I get 6x equals negative 6. Next, I'm going to divide both sides by 6, and I get x equals negative 1. Then, once I know what x is, I'm going to plug that into one of the original equations and figure out what y is. Just to mix things up, I'll use the bottom equation. Y equals negative 8 times, instead of x, I'm putting negative 1 minus 1. And negative 8 times negative 1 is positive 8. And positive 8 minus 1 is 7. So y equals 7. And I would write that as negative 1 comma 7. And that's my answer. Now I'm going to stop and make a separate video for the last few questions, or maybe a couple videos, just so the videos aren't so long for me to upload on YouTube.